Okay, hi, three's a charm here. Five is a charm was one of the last ones I recorded. Here we go. Let's go ahead and get started. We're going to talk about the nonlinear models. The last lecture, we talked about the linear models and using linreg on our calculators. And here we're going to deal with the quadreg, xreg, and the logreg. Okay, so we're going to be dealing with quadratic, exponential, and logarithmic equations. Now, you may or may not remember any of this from your previous learnings, so I'm going to go over what these shapes are. That's going to be important for when I give you a bunch of mixed questions in your homework and you have to find the scatter plot and decide what kind of equation we have. All right, so let's first investigate quadratic. So here is a scatter plot that I drew. It's not great, but I drew it. And I want you to take a look here and see that you can see that the data kind of starts, and we always look from left to right, and the data kind of starts from here and it goes around and it comes back down. That is the quadratic shape. The shape of quadratics can either be or like this. So it is either going up or down or down and up. Sorry, my board got tilted in between my teachings, I think. I don't know what's happening here, but I'll try to straighten it out. Okay. So quadratics are going to be in either one of these shapes, but the way that you can tell it's a quadratic versus an exponential or logarithmic is that the ends come back. So it always goes up and comes back, or goes down and comes back. And that is the only kind of equation where you get that kind of rainbow or a smiley. Okay, so it's either in the rainbow shape or a smiley. So rainbows and smileys. I need to say that today. Rainbows and smileys. All right. Okay. Let's take a look here and look at these exponential shapes. Now you get two kinds of exponential equations. You have exponential growth, where the function gets greater from left to right, where it kind of goes uphill. And then you have exponential decay, where the function kind of falls down a hill when you look from left to right, similar to when you're looking for a positive slope or a negative slope, or a positive correlation or a negative correlation. So let's look at these two, and we can see that this one here kind of starts low and then it kind of builds. This would be exponential growth. And here kind of starts high and comes down and kind of levels out. Notice it doesn't go back up. I kind of misnomered that with that line, but it probably more just goes straight out, and that would be exponential decay. All right. Now there's one more, and it is the logarithmic model, and that starts low. Just like the exponential and the quadratic, it starts low, but it comes up like a quadratic and then it flattens out. And it doesn't go back down and it doesn't go up any further. It kind of flattens out. It's like half of a rainbow. So this one is like half a rainbow. All right, but notice that it flattens. And it always goes in this direction. It always goes up and and flatten out. Okay. All right. Oops. Sorry about that. Okay, let's keep on going here. Let's take a look at our first example. Now, the first thing you should notice here is you must convert the dates. Okay, gotta convert those years. So here we're gonna let 1996 equals 0. So 97, so if this is 0, 97 is 1, 98 is 2, 99 is 3, 2000 is 4, 2001 5, 2002 6, 2003 7, 2004 8. Do not fall victim to the fact that the first one's 0 and the rest are 1, 2, 3, 4, 5, 6, 7, 8. Beyond that, it matters. Notice here that the difference between 96 and 97 is 1 year. 97 and 98 is 1 year. So this happens to be going up like that, but do not assume that that's going to be the case. All right. Now, I want to show you what the scatter plot will look like here. Now, you wouldn't really have to draw a scatter plot here or graph a scatter plot here because I told you already in the directions. I said the population of a town in thousands is given by the following data. Find the quadratic function. I told you in the question what kind of function, but I do want to make sure that you understand how to and remember how to find that scatter plot and take a look at it and see how it looks. Okay, so we're going to go over here and we're going to go stat. It's just like before. So we're going to go stat. We're going to edit our list. Here we're going to have 0, 1, 2 through 8, 3, 4, 5, 6, 7, 8. Okay. And then on our second list, we're going to have 25, 26.5, 27.1, 27.8. If we were in the classroom together, I'd be asking you to call them out to me so I wouldn't awkwardly be looking back and forth. But here we are. 27.9, 26.9, and 26.1. Looks like I missed one. All right, 25, 26.5, 27.1, 27.8, 27 or 27.8, 28.1, 27.9, 26.9. Oh, wait, so this is 0, 1, 2, 3, 4, 5, 6, 7, 8. What is going on here? 22. Oh, I missed that first one. And that sucks. I'm going to be quiet so I don't curse. I try to keep my mouth as clean as possible on these recordings. But no, on the inside, I am saying all sorts of terrible words right now because this frustrates me when I do this. Pretty tired, been recording all day. Again, just a little peek into the fact that everybody's human here. Okay. All right, let's see. And I'm going to make sure that they line up. They do. Hooray. Now, I'm going to take a look at the graph. Okay, so we're going to go zoom stat. That's going to give us our scatter plot. And notice what it looks like. It looks even better than the drawing I drew. It starts out low here, it goes around, and it comes back down. It doesn't have to come all the way back down, but you can see that its trend is coming back down. That indicates it's quadratic. So once you identify that, you're like, cool. We're going to go back here to stat, and we're going to calculate. And this time you're going to go down to, because it's quadratic, we're going to use quad reg. Okay, so we're going to go down here to option 5, quad reg. We're just going to enter all the way through here. Now I want you to notice here that the quadratic equation, and you might remember this from high school, but you might not. The quadratic equation is y is equal to ax squared plus bx plus c. Now remember, we're going to get rid of the y here, and we're going to, that stupid thing. Okay, we're going to get rid of the y here, and we're going to use f of x, right? Because that'll put it in the right function notation. We want it in function notation. Because that way it's very clear where we plug in the number. So here it's going to ask us to predict the population that was in 2010. All right, so for this equation and this equation only, so for quadratic only, you'll have three things you'll get here. You'll have an A, a B, and a C. Let me also remind you that our data went out one decimal place, okay? So our values that we use in our equation needs to go out two decimal places, okay? Data has one decimal place. Equation values must have two decimal places. Remember, one more decimal place higher. Okay, so our A here is going to be negative 0.21 because I need to only go out two decimal places. Do not give me that whole number. Do not give me that whole number. Do not waste your time on that whole number. Just however many decimal places I'm going to require by the rules. Okay, then B is going to be 2.084, so 2.08, and C is 22.962, so that'll be 22.96. All right, now our equation then is going to be f of x is equal to negative 0.21 x squared. Look, see right here, it says the equation right here at the top. You don't have to know this. You just have to plug the values into the equation that they give you in the calculator. Do you see that? Okay, so negative 21x squared plus 2.08x plus 22.96. I want to see this. I must see this. And then we'll finish this. Predict the population in 2010. Well, in 2010, we'll say 2010 minus 1996. 2010 minus 1996 is 14. So here now we're going to do f of 14 for 2010. And when you run that through the calculator, let's do it here real quick. So I'm going to quit this and I'm going to say negative 0.21, open parenthesis. And what is x here? It is 14, close parenthesis, squared. Okay. Plus 2.08, open parenthesis, because remember parentheses mean multiplied by, so you can just do that, plug in that 14, plus 22.96, enter, and that gives us 10.92. So we can say in 2010, the population was 10.92, and it isn't 10.92 people, is it? Does that make sense that the population would only be 10.92 people? No. Go back to your question. These numbers are in thousands, so 10.92 thousand. Okay, or you can move the decimal point or multiply that number by 1,000 and move the decimal point over to get the actual number. All right, so these are the things that I must see for full credit on the quiz and the exam. Okay. Let's look at the next example. All right, the following data describes the height of a ball reaches when it's following a determined distance. Find the equation that models this quadratic data. So again, I told you it's quadratic. So we will not spend the time to do the scatter plot. On your homework, on your quiz, on your exam, I'm not going to tell you what kind it is. You're going to have to do the scatter plot to determine what the shape is. All right. Just like on your first exam for Unit 1, I didn't tell you what kind of problems were working. I didn't say these are compound, these are annuities, these are loans. You had to figure that out from the clues in the question. You will have to do the same thing here by plotting the data and looking at the scatter plot and deciding what shape that is. All right, so we're going to skip the scatter plot here, but we're going to jump right in here with hitting up on our stat and entering in our data. So we have 0, 2, 6, 9, 12, 13, and 15. Okay, and then here we have 4, 8.4, 12.1, 14.2. I'm trying to be better this time. 13.2, 10.5, and 9.8. Check it. Cool. Hit stat. I already told you it's quadratic, so we're going to go for the quad reg. Write it there. Quad reg. Enter through all this stuff. Look at that. Now, check it out. See, I was all quick and fast. Look at that. It says linreg. I didn't need a linreg. I needed a quad reg. So don't worry about it. If you get the wrong thing, you know you're expecting 3 numbers here. It's quadratic. So go back to stat, go over to calculate. You haven't changed your data set, so just run it here. Now you got your 3 numbers. Looks like we need to go 2 decimal places here. I need all the information, so I would want you to tell me it's quadratic. In fact, I know I asked for 3 things. I asked you to tell me what kind it is. I don't know why I put a colon there. I ask you to tell me what kind it is. I ask you to give me the equation. So I'm going to give you the A, the B, and the C, because that's part of the equation. This is negative 0.12, 2 decimal places, 2.11, and 4.22. So our equation here is f of x is equal to negative 0.12 x squared plus 2.11x plus 4.22. This is the equation. The answer is not the equation. I need the equation and I need the answer, okay? And then now it asks us to find at 11 feet. So we're going to do f of 11, and I'm going to plug that in here. So we're going to say, I think I'm going to have to, okay, you don't have to hit clear. It just goes ahead and does it. That's nice. Times 11 to the power of 2 plus 2.11 times 11 plus 4.22, enter. And we're left with 12.91. Remember, let me go ahead and write what I did here. I don't really want to, but I will. Negative 0.12 times 11 squared plus 2.11 times 11 plus 4.22. Okay, that's how we got that. All right. And then we'll get that final answer here. The height. Oh, I don't know what happened there. The height when ball thrown 11 feet is 12.91 feet. Okay. All right, all right, all right. So again, this is another quadratic data one. So let's have this be a little you-do for you. Remember, you're going to use quad reg. And we know that because I said it right here. I said quadratic data indicates that guy. So go ahead and work on that, and I'll work on it here. I'll just work on it nice and quietly while you work on yours quietly. Now, oftentimes you can tell that data is quadratic if you look at the dependent variable and it either goes from big number to small number back to big number or small number to big number back to small number. You can see the pattern without actually even throwing it in a scatter plot. But if you're not sure, go ahead, scatter plot it, take a look, see what it looks like. Remember, this is the only kind of data that either starts low and returns low or starts high and returns high. Pardon me. Okay. Hopefully you've already done this at this point. This is a quad reg, so let's get down to it. We have A is equal to 7, B is equal to -3, and C is equal to this crazy weird number that you better not give me. That number is actually 10 zeros, and we're moving this decimal place 11 spots that way. So it's negative 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 2, 5, which essentially is nearly, but not quite, nothing. Right? If you started counting out the decimal places here, we got tenths, hundreds, thousands, 10,000s, 10 hundreds, 10,000s, 10 hundred, tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, trillions, 10 trillions, 100 trillions. That's 100 trillionth. That is negligible. Okay. But for the equation, let's have it All right. I'm not going to give you one with these crazy numbers necessarily on an exam. They're going to make more sense to a context to a question. This was really me just getting you to plug in these numbers and getting this kind of thing rocking here. So we've got this minus 3x, not plus, because it's plus a minus, right? And minus this crazy number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 2, 5. Now it also asks what it is when x is 5 and f of 5 is, skip this. We just plug it in, but I don't want to deal with this number. I'm too tired. I'm over it. This is me totally over it. All right, let's keep on going. Next example, the following table contains exponential data. Okay, exponential data, what we use for exponential data is EXP reg. So it contains exponential data. Does the data represent exponential growth or decay? Well, you can kind of look here and see that each number for each day gets bigger. So I'm pretty much going to say we're definitely exponential growth, and find the equation that models this exponential data. Then we'll finally ask a question: how many grams is expected on day 8? So let's get started. Let's hit here. Oops, wrong tool. Let's get here to the stats. Enter. And we'll put in 1, 2, 3, 4, 5, 6. And then let's go over here to 27.42. 55.31, 142.04, 411.79, 1250.7, 3859.7. Okay, make sure they're all in there. Okay, cool. Now I want to show you what the scatter plot will look like here. So remember, to scatter plot, we're going to go zoom stat. And you see, it starts low, it goes high, it grows quickly, it doesn't come back down, it didn't start up. I'm pointing, you can't see it. It didn't start up high here and then go back up. It started out steadily, slowly growing, and then shoo, shot up. That is exponential growth. Okay, so that is what we know. So now we're going to go back here to stat, calculate, and here we're going to go EXP reg. So we're going to have to keep on going down, and here we are. So you'll have to scroll all the way down to EXP reg, or if you're a hotkey person, you can just press the 0. So I'm going to hit 0 here. Scroll all the way through, calculate. Now, here's the equation that they give you here. It is y is equal to a times b to the power of x. Now that is up in the exponent. Remember what that caret means. That caret means to the power of, so that's up in the exponent. So the form you're going to use, it's not going to be that y equals. You're going to replace y equals with f of x. So here we got a is equal to, now let's see, how many decimal places do we need to go out? We need 3 decimal places, because this data goes out 2. This only goes out 1, but this went out 2. So for us to be precise and accurate, we need to go out 3 decimal places. So the A is going to be 8.163, because 162 here and the 7 next to it. So you'll have to round up. And then the B is equal to 2.730. Okay, and it's 730 because there's a 3 after it. You don't keep on rounding beyond. You literally go to the very next digit. It doesn't matter if that digit is a 5. You don't round that one to round the next one. You only go to the very next digit. All right, and so we'll put it in the form here. F of x is equal to 8.163 times, please use the parentheses when you write it out. Please do not give me a star and an air and a caret. I want you to prove to me the sophistication that you understand that there's a difference in the way that we write it and the way that we have to type it into a calculator. Okay, and then the b is 2.730 to the x power. It must have the x in it to be the equation. The x must be there to be an equation. Okay, so it's got to be there. So this is the equation, and then it asks, how many grams are expected on day 8? So that would be F of 8 because we were counting in days, and that was going to be our 8.163 times 2.7730 to the 8th power. And so let's plug that in over here. And so it is 8.163, open parenthesis, 2.730, close parenthesis, to the power of 8, enter. And we're going to need to go out. Let's see, we're 3 decimal places, so 4 because we've done another calculation. So this is going to be 25185.5229. And we can say we are to expect, or something like this, expect 25,185.5229 grams at day 8. Do not round this number. Give me the entire number. Do not say approximately. Give me the exact value. Okay? I am testing you on your ability to follow these directions and understand that every time you do a calculation on data, your answer has to be 1 decimal place more precise than the numbers that you use to calculate, even at this point down here. All right. Okay, let's look at another one. Exercise, or example 5, a box containing 1,000 coins is shaken and emptied on a table. All the coins showing heads are put back in the box, and this process is repeated. The trial data was collected and is provided in the following table. Find an equation that models this exponential data. Is it growth or is it decay? Now, we can answer the growth or decay question immediately by looking at the dependent variable. Is the dependent variable growing, getting bigger, or is the dependent variable getting smaller? In other words, is this growing or shrinking? Or shrinking? Shrinking, right? Is this growing or shrinking? It is shrinking, right? Started out 1,000, ended up at 45. So this is decay. This is exponential decay. Okay. All right, so let's put in our data. So we're going to go here to stat and we're going to edit. Zero, 1, 3, 4, 6. And we have 1,000, 610, 220, 132, 45. Let's make sure that that's cool. Yep. So here, because it said it's exponential, we know exponential is EXP reg. So let's do that. So I'll go stat and calculate and all the way down to EXP reg, or you can use the hotkey of 0. And here we go. Now we only need one decimal place here. So our A is equal to 10,018.3 because the 8 makes the 2 round up, and our B is equal to 0.6. We only need one decimal place. Okay, so our function f of x is equal to 1018.3 times 0.6 to the x power. This is the equation. Now it asks us to find what happens on the 5th round. So we would say f of 5 so let's get that. 1018.3 times 0.6 to the power of 5, enter. And this gives us 79 point, and now we need to go out 2 decimal places, 1, 8. So we can't have 79.18 coins though, right? So this is where you have to go back to the question. Don't give me an answer of 79.18 coins, because we don't deal in 0.18 coins, right? So we would then say that that's going to have to be 79 coins for sure. We can't say it was 80 coins because it was 79.18. So your best bet here is to go, it's called a floor function, where you go to the just the numbers outside of the decimal point. Sorry, my brain just went again. All right, so we're almost done here. So let me write our sentence here. And in the 5th round, 79 coins were face up. Okay, all right. Let's see, we got 2 more examples. Let's see if I can keep on paying attention. Let's see. Return on ad money spent is an important financial marker. The following table contains the number of ads bought for the first 8 weeks of a sales campaign and the number of stereos that sold that week. Find the equation that models this logarithmic data. For the logarithmic data, we use ln reg. ln reg. Okay. So the ads bought are our L1 and the stereos sold are L2. This is extra data. We don't need that. That's not part of it. Our independent variable is the number of ads sold. And our dependent number of stereos. Okay, so let's get to it here. Let's get here on our stat, enter. Clear it out. Let's get our things here. We got 6, 5, 3, 2, 1, 4, 3, 2. And then we got 20, 15, 12, 8, 6, 7, 9, and 7. Let's make sure that's all good. All right, let me show you what this graph will look like. Zoom stat. Okay, so I'm going to argue you could easily call this linear. And if you did call this linear and you said it was linear, then I would not mark anything off but 1 point for calling it the wrong kind. Okay? Literally 1 point out of your 12 points or whatever would fall into that. But I said it was logarithmic. So it doesn't matter what the data looks like. If I tell you what kind it is, then that's what you're going to have to go with here. Okay, so this is logarithmic, but it's hard to see, but there is a flow of the data that lends to that, but you guys are newbies and you wouldn't necessarily notice it. So like I said, if you saw this on a test or a quiz and you thought that it looked very much like it was linear, I would, and you worked it like it was linear and you gave me the equation and you gave me the answer and everything, I would mark everything right except for the fact that it was the wrong kind, but I would give you, say, if it was worth, like I said, 12 points, you'd get 11 of the 12 points if all the other parts were correct. Okay, so I don't want you to stress out too much, but I need you to notice the difference. Okay. So let's go here and let's calculate. And here we're going to use this LNREG, this LNREG. That's the number 9 guy. I'm going to hit number 9 and do all this entering like usual. And it gives us this equation. And this equation is, I'm going to write f of x, but it says f of x is equal to a plus b ln of x. Now, this is a function on your calculator. I'm going to show you. It's right here. Okay. So that is not, that needs to stay as it is. So you just want to follow what is written there in that equation. So we need an A and we need a B. And our A, we only need 1 decimal place. So A will be 3.7 and B will be 6.5. And our equation is going to be f of x is equal to A 3.7 plus B 6.5 ln of x. This is our equation. Remember, the equation has to have the x still in it. All right. And then it says how many stereos were sold in the 9th week. So let's figure that out. F of 9 is equal to 3.7 plus 6.5 ln of 9. And let's see how that goes in the calculator here. So we'll say 3.7 plus 6.5 ln, here's the button, ln of 9, close parenthesis, enter. And this makes no sense. 17.9, which is equal to 18.0. 3.7, 6.5, ln 9. Okay. The answer doesn't make sense. I'm going to get out my trusty calculator and just make sure that I'm not silly. But also know I make up all these problems. So there's a really good chance that this just might be a really not a very nice problem that I hadn't paid attention that it wasn't a very nice problem. Either way, the steps are the same. We did the work. Whether the answer seems to make sense to me or not is inconsequential, really. So much quicker and easier to put this stuff in if you actually have one of these calculators too. So this is my reminder for you to go get your calculator from the library. Nope, got the same answer. Okay, it's just a bad question. All righty, so our answer, you need to still follow through even if you think your answer's wrong. All right, and we know it's right mathematically, it's just a bad question. That's all right. So we expect to sell 18 stereos in week 9. All right. Let's hit one last one. This one is also a logarithmic problem. Here we have our L1 and our L2. So let's just put in our information here. We've got there, over up there. Here we go, 30, 40, 50, 60. Okay, so 30, 40, 50, 60, 70, 80, 90, good. And we'll go 19.2, 22.2, 4.8, 27, 30, 33, 2. All right, looks good. Now I'm going to show you what this one looks like too, because it might look better than the last one I did. Yeah, it looks a little bit better. It still looks like a line, but you can see it's kind of got a little curve in it. I don't know. Bad examples. But anyway, I told you that it was logarithmic, so you have to do it logarithmic anyway. So let's hit the stat, calculate, linreg. Here we go. Let's get our A is equal to negative 26.48. Our B is equal to 13.23. Let's get our equation. F of X is equal to negative 26.48 plus 13.23 ln of X. And then it says, what's the stopping distance at 75 miles an hour? That would be F of 75 is equal to, and let's put that in here. I'm going to do it negative 26.48 plus 13.23 ln of 75. That's equal to, let's see, negative 26.48 plus 13.23 ln of 75. Enter, and we get 30.640. And so, we would say that the stopping distance at 75 miles per hour will be 30.640 meters. And I know it's meters because that, and we're doing kilometers per hour. So that would be kilometers per hour. All right, looks good. I have been teaching for many hours today. Let's hit up this very last thing I want to say. The steps for success in data modeling. First, you enter in your data sets. Then you want to do a scatter plot and determine the shape. And that'll let you know whether you're dealing with a linear, a quadratic, an exponential, or logarithmic. If logarithmic and you have dates, you need to start the data count at 1, not 0. Okay, if it's a logarithmic data, you need to start that data count at 1, not 0. Calculate the appropriate regression equation determined by the scatter plot. You're either going to use the linreg, ax plus b, the quadreg, the exp reg, or the ln reg. Clearly write the equation in the proper form and answer the question using an equation and give the answer in a complete sentence. Okay, you guys got it all now. Please come see me if you need any help. I mean, to tell you, you guys are not taking advantage of my resources. So you guys come see me. All right. Have a great day. Good luck.